Okay, I think we are recording. Yeah, so before we start, as you noticed, the session is being recorded. So we're going to start with around maybe like 20-30 minutes discussion and then followed by Q&A. So either you can post them in the Q&A box, so your questions can be upvoted, or also you can put them in the chat, and then we can refer to them at a later date. My name is Kat To, your host for today, representing Terra.do. I'm a community ambassador currently based in London, where we host monthly events for the Terra.do community to get together in person. So if anyone is in London at any point, just hit me up and hopefully we can like meet up one day. So on to Pascal Joly. So he is product lead and AI and data solutions expert. He's an experienced leader with 25 years of experience in IT services and digital product development for large companies. He's the founder and owner of IT Climate Ed, providing consulting and education services in digital sustainability. He holds certifications in machine learning and LLMs, is a graduate of the INRIA Environmental Impacts of Digital Technologies Program, a Terra.do Fellow, and is certified in GHG Scope 3 measuring. Pascal, over to you.
Thanks, Kat, for the intro, and thanks, Terra, for hosting this session. So today we're going to talk about the cloud. And when you think about cloud, in our digital world, very often we have a picture of a nice blue sky with a few clouds and some greenery in the back. So very nature oriented, and we'll soon realize, and we're going to talk about today, how the reality is actually quite different. So just to complete the introduction that Kat just mentioned, I spent 25 years in the IT industry, working for both large companies like Hewlett-Packard and startup companies. So I'm an IT engineer by trade, and I evolved over time to become program manager, product manager, and I had a variety of functions. And a couple of years ago, I launched my sustainability consulting practice, and I help out companies to figure out how to build the bridge between the innovation and adopting new technologies such as artificial intelligence and continue to be sustainable and be mindful about the environmental footprint of using all those technologies. So today, what's on the menu? I want to talk first about the impact of these cloud services. I want to discuss also about how would you go about measuring the emissions from cloud services. And then I will discuss about mitigation steps you can take based on your role. And finally, we'll close and have a bit of an introduction about the course offering on this topic. I'll be opening the floor for Q&A after the end of each section, so we can have a bit of interaction. So the environmental impact of cloud, when you think about the overall digital emissions, back in 2021, we're talking about 3.8% of all the digital emissions. And in 2040, the projections could be about 14%. And a lot of it is due to the growth of artificial intelligence. And these 14%, think about it, it's a really large share. 4% was about the same share as the aviation, and 14% we're getting into industrial type of usage. So if you follow the path to carbon emission, you start with a cloud service, and here we're just using it as an example. For instance, a conversation with ChatGPT, which itself is hosted on the cloud. It's hosted on servers, actually running in data centers. And these data centers themselves are powered by usually fossil fuel, which this electricity that all these data centers require, very often, still 80% of the time, uses fossil fuel as the source of energy. And so if you look at what comes in and what comes out of these cloud services, first, you have to consider that every time you use a cloud service, you have hardware behind the scene. And this hardware requires mining with many, many different minerals that has to be extracted to have all the electronics in the servers and GPUs that you need to run those services, and also manufacturing, which itself is very energy intensive. And then you have the operation that most people usually talk about, which is not just about electricity, but it's also about water, because all these servers, they need to be cooled down. And in order to cool down the servers in the data center, you need a lot of water. And finally, these electronics, they have a limited shelf life. And usually after 1 or 2 years for end devices, or 5 years maybe for data center servers and equipment, they have to be either recycled or they end up in landfill. And so we have a big e-waste problem. And just to put that into perspective with a few data points, if you look at, for instance, the example of tantalum, which is a mineral that's used in all capacitors, and pretty much all servers require that. In order to obtain 200 grams of tantalum, you need to extract and mine 1 ton of ore. So that gives you sort of the magnitude of the mining that's needed. And in order to power all the data centers, it's going to be using 4 to 6% of the global electricity production, knowing that it's actually concentrated in a few countries in the US, China, and some countries in Europe. So it's not distributed equally. And finally, in 2024, 69 million tons of e-waste were generated by electronic devices. And this number is actually keeps growing up. So I want to just dive down a little bit on rare earth mineral, because there've been a lot of discussions in the news, especially earlier this year with the war in Ukraine, with Greenland, about the fact that we need those rare earth minerals to build this capacity and all those server equipment. So rare earth minerals are not rare per se, but they're very dispersed, and as a result, very expensive to extract. They're also concentrated in a few places. China holds about 60% of them. You find them in Australia and then other countries, but very few of them. And as mentioned, a lot of people are talking about where else could you find them potentially, and that's why Greenland and Ukraine were mentioned in the news. And these rare earth minerals are used pretty much everywhere. So they're used in GPUs, in hard drive, in fiber optics, so the network transmission between data centers. They're used in cooling equipment. And in order to mine the ore, you need a lot of water. And essentially what you need is to filter out from the raw material what's actually useful. And as a result, what you do is pretty much brute force. You use a lot of water, and this water gets contaminated with a lot of different radioactive materials, heavy metal, and it needs to be disposed of. If possible, in a place that's safe, but usually it ends up not too far from a groundwater, and it pollutes it. It also is carried over through pipelines away from the mine, and these pipelines often leak. So as you can see here in a picture of one of those mines in California, this is really, really huge, and a big problem, because very often those mines are in desert areas, which already lack water. And this data center buildup is not slowing down. So we've seen in the news just a couple of days ago that Amazon is going to invest 20 billions in data centers in the US. And some of those data centers, like the one planned for Texas that was announced earlier this year for the US, is going to be powered probably for the most part by natural gas plant, which is fossil fuel, emitting fossil fuel. So the question now is how to measure cloud carbon footprint. How do you measure this carbon footprint? But before I jump into that topic, I want to open up the floor if we have any questions about the environmental impact of cloud computing. And I know I've discussed about AI because it's been really front and center in the news quite a bit, but the digital cloud computing is not just about AI, right? Everything that you do online essentially is in scope here of this discussion. I'm just checking if we have any question in the chat. And feel free to unmute your mic if you have any question. I see that.
Giacomo, do you want to come up and ask your question live to Pascal?
Yeah, sorry. Sure.
No worries.
Yeah, so I know we're still on the topic of life cycle, but this might be a little bit further ahead in the presentation. But I wanted to ask, when we get to it, if there are any policy or interconnection obstacles that you see currently that would hamper the ability for data centers to either offset or completely switch to renewables for in the future, such as to be completely powered by that. How realistic is it?
Okay, so if I want to rephrase your question, you're asking what sort of the mitigation strategies for data centers to power them with either renewable or cleaner energies, right? Is that correct, Giacomo?
Yes.
Yes, so it's a good question first. And the way I like to answer it is that there are a lot of investment in different solutions from the cloud providers to mitigate and decrease those emissions because they have all made commitments of emission targets to have net zero emission targets. And they're realizing that with this data center growth, they're not able to meet that at all. They're really far from meeting those targets. And so they've been trying to employ a few strategies. One of them is through power purchase agreements. So they have long-term, they buy their power essentially many, many years ahead with the utility companies. And the way it works is that they will have a 10-year agreement to buy some solar power or maybe even to build a nuclear power plant or help fund a nuclear power plant. And they will have a slice of that power that will be guaranteed for their data center. And as a result, they can claim that they will have clean energy for these data centers. Up until recently, the cloud provider used a bit of an accounting trick so that they could claim clean emissions in one area and sort of aggregate it over the period of a year, disregard the geography. So maybe offset an emission of a data center that's located in a place where you don't have clean energy, but offset it with buying or building a solar power plant in a totally different area or region of the world. Now, there have been some efforts recently to change that and have 24/7 energy that's location-based. And this is an effort that's been spearheaded by Google and Microsoft. And this is much harder to achieve, of course, because now you need to procure your energy, not just when the sun is shining at the data center location, but also when renewable might not be available, so you need battery technologies, or you need energy that continuously is provided, such as hydropower or nuclear power, but these energies are in very short supplies. So right now there's a race to build some of those large projects everywhere around the world, and it's competing with other needs that are going to need also a lot of electricity. So think about powering homes, powering industrial use with electricity, and powering vehicles. And so that's the sort of the issue that we're facing and the challenge that we're facing right now. I hope it answered your question. It was a little bit long and convoluted, but I hope it answered your question.
Yes, thank you.
All right.
Thank you.
If we don't have any other,
There's one more question.
Oh, there's
Sorry.
one more question. Go ahead.
Yeah,
Go
there's
ahead.
one more question from Charles. Charles, do you want to come off mute? If not, I can read it on your behalf.
Sure. Hello, can you hear me?
Yes,
Yes,
you can.
I can hear you.
Great. Yeah, there's a lot of information about water usage in data centers, and I often read it as being quite a serious issue. But then I've also read that a lot of data centers have closed loop cooling systems or air cooling systems. So I just wonder whether this issue is exaggerated or yeah, I'd be interested to hear what your thoughts are.
Yes. So actually, it's not exaggerated at all. And the reason is because of a completely closed loop system today, and you're talking about cooling, right? Specifically, it doesn't exist. So there's always some losses. And today there's a measure called the power usage efficiency for data center and water usage efficiency. It's two different metrics that are being used. And if you look at these metrics are essentially overhead that's required either to power the servers and cool them down, or the water that's required to cool them down, as compared to just purely the power needed to just plug in their servers to the grid. And there have been various attempts to do closed loop systems to cool down those servers and decrease the overhead. But right now, the best systems, the cutting edge systems in data centers achieve about 10% overhead. Sometimes just a little bit under 10%, but you think about the amount of power required total by a data center, like 100 megawatts data center, for instance. If you had a 10% overhead, that's 10 megawatts of power that's just needed to cool down the servers. And we're also talking about millions of gallons of water. They're trying to recycle this water over time, but there's always losses, and also losses due to evaporation and due to water not being at the cleanliness that is required. And so there's always losses. And so even with water efficiency, we're still talking about millions of gallons of water for the most efficient data centers.
Thanks.
I hope that answered your question, Charles. Thanks. All right, so let's move on to the next topic, which is also a very, very big topic that we discuss a lot in the class, how to measure your cloud carbon footprint. So many of you might be familiar with the greenhouse gas protocol, scope 1, 2, and 3. So scope 1 is your direct emissions, scope 2 is your electricity, so emissions coming from electricity, and scope 3s are both upstream activities and downstream activities, so emissions resulting from both of those activities. And if you look at this from a data center operator standpoint, scope 1 emissions would be reported as the ones that are directly used for running the data center, including diesel generators that are used as backup when there's a power outage, because data centers run 24/7. Scope 2 would be all the emissions to power your data center. And then scope 3 upstream activity would be maybe emissions from server manufacturing or also the data center buildup. And then Scope 3 would be the server end of life and all the emissions resulting from transporting the servers to a different location and processing those servers when they get into some kind of recycling facility, for instance. And so how do you measure and report these with there are a few approaches, and one of them is to use cloud provider dashboards. So all the main cloud providers are giving you some options to figure out your emissions from your usage of cloud services, but they're not all equal. And I have a little podium here with first place, second place, and third place. I'm just inviting you in the chat to put what would be your ranking between the three leading cloud provider, Google, Microsoft, and Amazon. So what would be your ranking between 1, 2, and 3? So feel free to put this in the chat. It's always interesting to see what people come up with. Okay, somebody said Google Cloud first, second Amazon, Microsoft, third Azure, AWS first, Google, Microsoft, Amazon. Okay. It seems like you are actually, some of you are pretty close. So the number one is actually Google, that provides the most granular reports, including scope 1, 2, and 3. Microsoft is, I would say, close second, and AWS is distant third and still doesn't provide scope 3 emissions. So any AWS customer, we essentially involve enrolling potentially consultant, and there's a lot of heavy lifting essentially to get to your consumption if you are an AWS customers, which, as we know, millions of companies are AWS customers. So what does a dashboard look like? So this is an example with Azure emission. So you'll see sort of a breakdown between your different emission scope, your total usage, and what's more interesting is the breakdown by subscription, which for a company, you'll have many different subscription, which aligns very often to teams. And then the evolution, of course, over time of your emissions. And Microsoft provides this map that allows you to look at very simply the carbon intensity of the services that you're using. And carbon intensity is a very interesting concept. Essentially, it's helping you figure out how in a given region of the world, the main power comes from and how polluting is that power with respect to its greenhouse gas emission. So if we look at this partial map of the world here, you will see that in Quebec, for instance, in this sort of in the middle of this map, we're very green because mostly it's powered with hydropower. If you look at maybe Eastern Europe, in Poland, it would be dark brown because it's mostly coal power. In the middle of the US, which is actually where we have a really high concentration of data centers, we're going to have actually fairly dark brown, a lot of coal and gas powering those data centers. And the tool I'm mentioning here is called Electricity Maps. If any of you is not familiar with that, it's a really, really good tool with an API that allows you to dynamically pull out this carbon intensity because it changes all the time. At any given point in time, power could come from solar. So if you look, a good example is California, which, if you look at daytime, carbon intensity very low, and then it increases at night because California imports some gas power. And so that's why it's very useful to be able to pull dynamically this information about carbon intensity. And data center will be usually mapped fairly closely to this carbon intensity, except that they might have a share of clean power that's not reflected here that they have negotiated with the utility company. So that's still an area that where we don't have full visibility when you want to measure your cloud emissions. Another tool that I wanted to mention as part of this presentation is a Python library called CodeCarbon. So there are a few Python libraries that enable you inside the code to track down your emissions. And this is very useful for any code that's going to be running in the cloud and have the ability to fairly precisely pull out the data from the GPU there where the code is running on, or the CPU, near real time. And then you also have the ability with CodeCarbon to calculate the carbon intensity from electricity maps, so retrieve it directly from electricity maps. And it gives you as an output an educational dashboard with a lot of information to build awareness on these carbon emissions. So here it's both a tool that's fairly good for accounting, carbon accounting, but also good for educational purpose. And then you have all the carbon management platforms that can help you aggregate the cloud carbon emissions as part of your broader company's carbon emissions. And so you have dozens of them. This is just a snapshot of these platforms for North America, but there are many of them also in Europe, in Asia Pacific. And these platforms quite often do a good job of retrieving that information, consolidating it with other carbon emissions, such as your employee travel, your office's emissions, and give you kind of a single dashboard that can be integrated with your FinOps, for instance, dashboard, your cost consumption. And I wanted to mention also some platforms that are specialized in IT and cloud carbon accounting. Some of them are actually, most of them here are based in Europe. You have Fruger, GreenPixie, and Resilio, and they all have slightly different ways of reporting these emissions, but they are very specific to help you manage the gaps that cloud provider can give you, especially if you're an AWS customer or if you're a multi-cloud customer as well. So these are very good products. They also will quite often include not just the operational emissions, but they will attempt to also add the embodied emissions, which is the hardware, the manufacturing emissions from building the hardware that you're using, and the end of life emissions. So they will give you an estimate based on the hardware you're using. So that's just a quick overview of those platforms and measurement tools. Any questions before we move to the mitigation and solution section? So again, I'm going to open the floor for questions. Yes?
We have two questions. One is from Anurag, which is a more generic one in terms of skills. Do you want to come off mute and ask the question yourself? I'm also happy to ask on your behalf if you're not able to. I think I can ask. Okay. So the question is, as someone into their early careers, how do you recommend learning cloud and DevOps from scratch, considering sustainability and climate tech? And then the second part of that is, what skills would you recommend, especially with incoming AI, as it consumes more electricity and water, that are at an intersection of AI, cloud, DevOps, and climate tech / sustainability, such that those skills can be useful to scale climate tech solutions sustainably? It's the Q&A in case you need to refer to it.
Yeah, so we got a few questions within that, but essentially it's about skill sets, right? If you're getting started in this field, so the first thing I want to say is that any job can be a climate job, right? So it's not just because you don't have sustainability in your title that you can do work on sustainability. I used to be an IT engineer, and as part of my job, I had to figure out some ways to decrease waste, for instance, and that was the core of the product that we were building in the startup company that I joined before launching my consulting practice. So think about your jobs and as a job that could be aligned more to technology and cloud, but everything that you will do as part of your job you will try to apply some skills that are tied to sustainability. And the best way to get educated on that is to take courses such as the courses offered by Terra.do, and there are many others, to understand a bit better what's at play based on your role. And in the next section, actually, I'm going to go over different roles that you might have in a company that are tied to cloud and technology, and some of the levers that you would have based on what hat you're wearing in your job. So assuming that you have a role that ties somewhat to cloud or ties to DevOps, what can you do to make it more sustainable? So actually, that's a very good transition section for the next part of this presentation. Any other question that we have?
We have
I'm looking at
more. One from Johnny.
Mm-hmm.
Johnny, do you want to go ahead and come off mute?
Yeah. Hi, Pascal. So my question is around
Hello.
GHG emissions calculation that the cloud providers publish.
Mm-hmm.
How do they really calculate these user code executions? Because they may be distributed across various servers across their geographies for, say, load balancing perspectives. Do they really calculate at that granular level on the GHG emissions?
Yes, so that's a good question. And you pinpoint actually a challenge that we have today, which is there's no standard on cloud providers having to report their customers' emission one way or another. So the lack of standards means that every cloud provider will give you a slightly different report or a slightly different calculation, essentially. And the second aspect is quite often the lack of transparency. So those cloud providers, they have ways to calculate these, and they make a lot of assumptions and estimation based on what's running in the backend, but they don't necessarily disclose how they do it, or at least don't necessarily disclose it at the level that you're talking about. And so the best way is to ask the right questions. When you have your customer of a cloud provider, you have an account manager if you're part of a company, and usually you're able to ask those questions and then figure out based on the answers which one do you trust the most, and do your own critique essentially of which way you would go to and which way do you trust if you haven't made the decision yet on choosing a cloud provider. Some cloud providers, which are not part of the big three that I mentioned here, are going to be claiming more green credentials, but they are usually in the minority. And for the most part, as far as I know, they're based in Europe. So you might be limited by the type of workload you want to run based on your geography. Does it answer your question?
Yeah, it does. And all these workload-related emissions are scope 3 for the cloud provider, right? They are user emissions for them.
So from the customer of the cloud provider, they're always scope 3, yes.
Thank you. Thanks a lot.
Yep. All right.
There's one
let's discuss
more.
about, one more question.
Sorry,
Yep, go ahead.
one more from Charles.
Mm-hmm.
Hello again.
Hey.
Yeah, the three platforms that you mentioned, I'm just curious as to what differentiates them from the other platforms. So like what specifically would they do? Like how would they integrate, say, to the carbon footprint of data centers versus the other platforms?
Yeah, so these platforms, they have built sort of an expertise around IT and IT services. So it's not just about cloud, by the way. It's also about your company's digital assets or hardware assets, I would say. So if you have laptops and mobile phones, they will also build an inventory of those and try to assess the life cycle assessment of this equipment. So they will go beyond cloud, and they have built an expertise that makes them very knowledgeable about the challenges and the differences between the major cloud platforms, so that they are more they're able to be more accurate essentially on the report that they will give you. So it's really about, many of those carbon accounting platforms, they actually tend to lean towards certain industries, even though they claim to be generic. They usually have, maybe they're focused on garment industry, or maybe they're focused on the mining industry. And you'll see very quickly, where the DNA comes from. And so if you're looking specifically to solve, your carbon emissions from the cloud provider, I would recommend, to go with somebody who is very knowledgeable about that topic. So that's sort of my take on this. And that's why I mentioned those three carbon platforms, because I know, I've worked with them to some extent, and I know that they are really, they really provide some pretty solid solutions.
Brilliant. Yeah, thank you.
All right, so let's look at now the mitigation. What can you do, and based on your role? So I will start with the cloud architect, and some of you might not be cloud architects, but these are the people who are going to design the system or the product in the first place. And they could be designing machine learning systems, or they could be designing a SaaS product. But the goal here, when we talk about sustainability, is to minimize the environmental impact while trying to keep the balance with efficiency, scalability, and resilience. And so it's really a very tricky balancing act, sometimes walking on the tightrope to be able to manage all those components. And how you do that is by applying a number of principles. And I'm going to touch on three of them today. We really dive into these much more in depth in the class. The first one is about data. And the two things that you might be able to do here is, how do you minimize or optimize the storage of the data? And that could mean compression, deduplication technologies. And how do you minimize transfer? So technology like caching, or making sure that you only transfer data that you need. These are techniques that you can apply around that topic. And pretty much any architecture will require some type of data component. The second aspect is all about density. And here, many people who are already familiar with DevOps and with cloud architecture, with Kubernetes, they know about containers. And essentially, the more dense you are, usually the better, the more sustainable you are, because you're maximizing the usage of your hardware in the backend, and you're minimizing the idle part of your hardware. So increasing the density is actually part of these principles, and something that you should be thriving for. And the next point is about elasticity, which means dynamically making sure that you build a system that can dynamically adjust its hardware usage based on the expectation of the workload. And that means spinning up dynamically resources, containers, or VMs if you are expecting the demand to grow, and shutting them down when the demand is low. Think of it as a roller coaster, for instance. And there are many different services provided by cloud providers like elastic load balancing that enable you to do that, as well as Lambda functions, for instance. The other piece of organization that's going to be involved are your developer teams. Any cloud job nowadays involved usually some type of development with scripting, and you're going to work very closely with development teams. And here, development teams, they have a whole set of tools aligned to green software development. And there's a foundation, the Green Software Foundation, that provides a lot of details about that. Some of those principles involved emission tracking functions, and we talked about Code Carbon as an example. Others are involving optimization techniques. So when we talk about machine learning more specifically here for training and inference. And again, right sizing, so building in your software the ability to support right sizing, especially when we come to development infrastructure. And then you have your QA teams. And QA teams, again, we're talking about making sure that you use only the amount of resources that you need for doing your QA. And of course, if you're doing performance testing, you're going to need a lot more resources than if you're doing just a simple feature test. DevOps principles do apply here because automation usually is good for sustainability, and shutting down those machines that you don't need anymore is super important. And applying the ephemeral infrastructure principle essentially is what we're talking about here. And finally, last but not least, you have the IT ops team. So here it's all about choosing the cloud region that has the lowest carbon footprint. And here again, electricity maps is a huge, very, very useful tool. And tracking your energy and carbon emissions over time, like we discussed in the last chapter, is also very important to figure out where you can improve, and mitigating that with obviously workload placement based on performance requirements, as well as potentially security and law and regulation requirements, is going to be something that's needs to be put on the table when you have those meetings about where to deploy your product or your cloud services. And finally, tying to this green ops topics, which is really what I was discussing in this slide here, is how do you build the business case to make your cloud more sustainable? And here, the number of things you can do, very often tying the cost savings that will result from improving the efficiency is going to be something that resonates with your management. The other part is that many customers who are becoming more conscious about the emissions of cloud services might want to ask you about that. It could be in RFPs or it could be in contract renewals. And here it would be very important for not just for your brand image, but also to maintain a competitive advantage, to be able to justify that you are doing the best you can and you're actually able to save, you're mindful about these issues. And finally, there are many rules and regulations that are coming up around the reporting of cloud services. Europe typically tend to be the most advanced, but the international landscape right now is evolving around that. And you have also places in Asia Pacific as well as in some states in the US that are pushing for more regulation and more transparency about companies having to report. And so anticipating about this and being proactive is going to be helpful once these rules become enforced. Any questions on these sections and what can you do? I know it's a lot of information, but just for today's session, I just wanted to give you an overview of what is possible.
I don't see any additional questions.
Okay. All right, so if we don't have any more questions, I'm going to move on to the last section, which is what can you do as your very next step? And we talked about education earlier on as part of the very first step that you could do to get more familiar with this topic. And Terra is offering a course on sustainable engineering that's very in-depth, about covering all those topics that we discussed today, plus more. It's a self-paced training that usually takes about 4 weeks to cover, if you want to really be diligent about it and have an exposure to all those topics. And it's a course that also offers office hours, so I'll be available once a week to answer any of your questions, specific questions about the course, but also about your own context, your own company, and you can ask me questions about the homework assignments as well. So we'll have sprinkled throughout this course, we have testing quiz, and you might have also questions about that as well, or things that you didn't quite understand. And finally, you receive a completion certificate. So I put a QR code here that gets you directly to that course landing page, where we have detailed information about the material that's being covered. And I'm open for Q&A now. So if you have any final question about the course, about the presentation, now is the right time.
And feel free to come off mute and ask your question. Oh, there's a few coming through. Okay. Georgia asked, how much does it cost to take the course?
So I believe it's priced at $3.99. Yeah,
Is that US dollars?
Yes, US dollars. Sorry.
Yeah. Charles, I don't know if you want to come off mute again.
Sure. Yeah, so you've mentioned a few different actions that can be taken. I'm just wondering which are the most impactful in terms of, which are actually going to, say, reduce emissions the most.
So usually you will identify the most impactful actions based on your measurement. So that's why all the time I suggest first create a baseline and know where your highest emitters come from, and then figure out the course of actions, maybe changing the region that you're deploying those workloads, or it could be also minimizing waste. But the first place is really to do a complete analysis of all your digital services and consumption, and then rank them and look at the low-hanging fruits, essentially, where you can achieve the most benefits without having to rebuild completely your application, right? So that's usually the proper step or process.
Cool, thank you.
There's a couple of questions in the chat from Shori. Do you want to ask a question, Shori? If you're able to.
Oh, thank you. So I just want to ask you for, like, in general, I mean, it's it's a big issue, and the AI is growing, like, and so how do you find it as a, considering the energy demand and climate mitigation, and are you finding it like getting worse? I mean, because it's growing so rapidly, and I mean, how do you find it as an issue in, overall?
Yeah, so if we're talking specifically about AI, we have actually a presentation next week, which is another course that Terra offers on sustainable AI, because by itself, it's a pretty large and very hot topic right now. But just to answer your question, if we don't do anything and if we keep business as usual, this problem is going to become exponentially worse. And we're talking about energy and all the emissions as well as environmental impact of AI. And so that's why bringing awareness from the bottom up to those issues and getting more people involved to understand what are the mitigation strategies and how we can bring more mindfulness and efficiency in our usage of those technologies is very important at the moment. So this is really kind of a pivot point, I would say, that is, yeah, that's happening right now.
Thank you. Thank you very much.
There's two more questions, one from Laurie and then one from Marie. And seeing as we've got 4 minutes, in the interest of time, I will just read them out for you quickly. So Laurie asks, she's curious about the percentage of the data centers that are owned by the big 3 cloud companies. Like, do you know what the percentage is?
Okay, so this question is maybe should be reframed because there are many, thousands and thousands of data centers worldwide, and many of them are actually still pretty small. But the large big 3 companies, they have built clusters of mega sized data center. And these are 10 or sometimes 100 times larger than your typical traditional data center. And these are the ones we're most concerned about. And these companies have, I would say, about 80% of the energy consumption resulting from all the data centers. And I wouldn't say that smaller data centers are necessarily more energy efficient. They just consume a lot less energy. So that's sort of how I would reframe the question. They don't necessarily own a lot of data centers. The large, it's not just cloud companies, by the way, but it's all the, I would say, leading tech companies in the world. So it could be OpenAI, it could be Meta, it could be China Telecom as well. But it's more about the size of the data center and the energy that these data centers consume, which are gigawatts of energy for the larger government.
Thank you, Pascal. And then final one, Marie asked if you need a technical background to be able to do the class. And I think that's a good one to end on. Yes,
I would say it's good to be knowledgeable about the terminology of cloud computing in general. You don't need to be very technical, so I don't think there's no coding exercise required. I think general knowledge about some of the terms used in cloud engineering, and there are pointers in the class about these, will help you get started quicker and get the most value out of the class. Yeah.
Great. Thank you so much. Thank you for your time, Pascal, and for spending the last hour with us. I learned quite a lot of stuff, and hopefully for everyone who's interested in the other session that Pascal mentioned next week, I think you can just join up on the Terra.do site. So hopefully we'll see you there. And thank you everyone for attending.
Thanks everyone for attending.